Okay, so welcome to today's topic. Today's topic is how to create your own class and object. We touched upon this subject a little bit in previous sessions. Here we are going to learn a bit more detail. All right, so let's move on to the next slide. So objective of this presentation and hands-on lab is again learning how to create your own class and how to declare properties and methods when you're creating your own class, and how you can use what is called the this reference to make a reference to your own object instance, what is called the current object. And we'll learn the concept of overloading method, and we'll talk about access modifier such as public, protected, and private, how those modifiers affect the scope in which you can access members of your class. Okay, slide number 3. So let's see how you can define your own class. So notations that we are going to use is when you see the start, that means 0 or more occurrences, and the description and square bracket means that part is optional. So defining the class follows this pattern. So you have modifier and you have class. This is a keyword, a name of your class, and then inside your class you have a set of attributes or properties or fields. Those are all same thing. And then you will have a set of constructors or constructor methods, and then you have your methods. So let's see a simple example. Here we created a class called student record, and we made it public, so that's one of the modifiers, and this is a keyword class. So we are defining student record class. Coding guidelines, as we talked about before, the most important thing is that the file name of your class must have the same name as your class name. Otherwise, it's a compile error. And the first two are mostly recommendations. Typically, you want to name your class with a capital letter as initial letter. But it's just a recommendation. So the first recommendation is the class name should represent what you are trying to create, and also the second bullet is basically class name start with a capital letter, as I said before. Okay, moving forward. Concept of instance variable and static variable. Then we'll talk about instance method and static method. So we touched upon these things a bit in our previous session. So instance variables belong to an object instance. So different object instances from the same class will have a different values for those properties or fields. Class variable, however, is sometimes called the static variable. It belongs to a class, and all object instances in fact share the same class variable. So if you in fact change you will see later on that you can access class variable from object instance. That's perfectly fine. But if you change from one object instance the value of a class variable x, that change will be visible to all the other object instances, because there is in fact only one area this class variable is actually maintained for all object instances. So this picture actually shows the difference between instance variables and class variable. So instance variable, this is a class, this is a car class, and different object instances will have a different values for their properties. However, class variable is shared among all object instances. It belongs to a class. Okay. As we talked about, instance variables belong to object instances. So when you declare properties or fields or an attribute, or same thing, these are the syntax. You have modifier, For example, public, private, protected, and then you have to have a type. This is a must. If you don't specify a type, then it's a compile error. And then you specify name of that variable, and then you can also specify the default value, but that's optional. So let's see an example. So here inside student record class, we are defining instance variables, and this private, this is one of the modifiers. We'll talk about different types of modifiers later on, but basically you can specify private, protected, or public. So here we are setting private, means this variable will be visible only inside this class. Okay, so we have defined 7 instance variables or instance fields. So set up coding guidelines. So declare all instance variables right after public class, my class. These are all recommendations, by the way. So so declare one variable for each line instead of multiple of them in a single line. And instance variables start with a small letter typically. And this one is a mandatory. You have to specify the data type for each variable or each field you're declaring in your class. And declare instance variable as private so that only methods in the same class can access directly. So this is actually for the encapsulation, meaning you want to hide detailed implementation as much possible from the user of that class. So if you make it private of your variable, then it's not going to be visible to the outside. Instead, you are going to use what is called the getter and setter method, which we are going to talk about in a few minutes. That is the way that you want your user of your class to be able to access those fields. Okay, static variables. So in order to declare a static variable, you say static. Okay. So we use a class keyword static to indicate a variable is a static variable. So that is basically only thing you have to do to make it as a static variable. So question from Mahesh: can subclass access class's private variable? Yes. It depends on actually scope that we are going to talk about. I mean the modifier, for example, public, private, and protected. Depending on the which modifier use, a subclass might or might not be able to actually access it. But there is a way of actually access it. So we'll talk about it. Okay, moving forward. Methods. So how do you declare methods in your class? Basically, again, you provide a modifier. Again, this is going to be either one of those 3, actually 4, including default. Again, we'll talk about these things in detail later on. Private, public, protected, or nothing. And then you specify return type. And then name of a method. And then set of parameters, and inside this brace you provide the business logic in the form of Java statements. Okay, so concept of accessor method, sometimes we call getter method. Accessor method is basically, it is a method that you want to follow the pattern using get and name of the instance variable. Okay. Again, this is actually recommendation. I mean, it doesn't have to be this way, but Java Beans pattern actually recommends you follow this the naming pattern. So get name of instance variable. So let's see an example. So suppose I have a name variable, as we talked about before. You want to make this one as private so that the user of this class cannot directly access to it. Instead, you are going to provide access to this name variable by providing a method name called the getName. Okay, so if this is the name is XYZ, then the name of this method is going to be getXYZ. and then you are going to return that the value of that particular field. So this is getter method. The reason it's called getter method is because it is a method the user of your class, in this case a student record class, can use to access the value of name private field. Okay, so we talk about these things. So this is the keyword, and then this is return type. So this return type has to match the type that you're returning. Otherwise, it's a compile error. And this is the name of the method. Okay, example 2. So here, you can have a getter method that does not actually depend on private field. Instead, it might actually compute the return value using some business logic like this. And the reason this is actually useful and important is because, again, this is concept encapsulation. Sometimes you might want to change the business logic of how to provide the average, value of average, through the getAverage method. If you make, let's say, average field directly accessible like a public to your user, and the user can directly access it to it, later on, if you want to change on the scheme of how to, let's say, compute the average, instead of reading it from a private field, you might in fact perform some business logic. You might in fact go to the database or go to web services and then compute the business logic. So by having this method is the only way that your user can access this average value. Your implementation can change without affecting your client code. On the other hand, if you make, for example, average as a public, and the caller, the client code has to change if you in fact if the implementation in fact change. So that is the concept of encapsulation. Yeah, I'm not sure I actually explained the concept clearly, but I will have another chance to talk about it, but feel free to ask a question about it. Okay, so we also have what is called the Mutator method, and Mutator method sometimes called the setter method. So getter method is for retrieving the value of something, right? Mutator or setter method is used to set the value of a variable. So instead of using get, you're going to use set, and then you're going to use the name of that variable. So for the same class, we have a private name field, and we now have a set name method. And you have to pass parameter, in this case the name that you are going to set with. So here we are going to use the parameter, in this case temp, and we are setting the field of name. Okay, moving forward. Multiple return statement. You can have multiple return statement as long as they are not in the same block. So let's see an example. So in this case, we have used return statement in 3 different locations. But as long as they are not in the same block, you can't have return 1 and return 2 in the same block. That's kind of obvious, right? So in this case, this is a method, right? So this is a get number in words method, and it's receiving num, which is int type, as a parameter. And based on the value, we are returning a string object. So here we're returning 1 as a value of the string object. We are returning 2 as a value of string object. Here we are returning the default number. Again, this is a string type. So as you can see, the return type string has to match to what you are returning. So if you try to return, for example, number 3, that is gonna cause compile error. Okay. Moving forward, we touched upon the concepts of static variables and instance variables, or instance fields, or static fields. Now we are moving forward with the same concept but applied to methods. So a static method, the way that you are going to declare a static method is again using static modifier. Okay. Now, as you will see later on, I'm gonna just move ahead. Okay, so this one is basically the caller of the static method can use a class name, right? Instead of object instance. Again, we touched upon this concept several times before. So coding guidelines for method names. Again, method name should start with a small letter, and method name should sound like a verb. Okay, and having documentation is always good. These are kind of too obvious. Okay, so when do we want your method to be static? Okay, so we touched upon these things in previous session as well. So let's actually repeat a bit. When the logic and state does not involve object instances, meaning different property values of different object instances do not play a role in the logic. For example, like a computation method such as add, int x, and int y, meaning the user of this method will provide everything. In this case as a parameter. So it doesn't actually involve any object instances of this class. So in that case, you might want to in fact build it as a static method. If there is, let's say, object instances coming in as one of the parameter, and then you might have to actually make it as the non-static method, meaning instance method. Another situation that you want to make your method as a static is when the logic is convenience without creating again object instances. One of the examples that we have seen in the past, in the previous session, is parse int method of integer class. Okay, so you are basically passing string object, and the string object will contain some value, a numeric value like a 35, and it will return the int type. Okay, so these are student record and these are instance variables because it doesn't have any static. Okay, so this is something we have seen before. Now we are going to this is a complete code, so this is a little bit of repeat. This is getter method and this is a setter method. You can see these are instance methods rather than static method because it doesn't have a static modifier. Here get average, again this is an example of instance method, and this is a static method, so we have a static. Okay, now if you actually see this example, the reason, let's say we want to have get average as an instance method instead of static method is because it's using the properties of object instances, meaning each object instances will have a different value of math grade, English grade, and science grade, right? Because they are defined as instance variables, right? So you cannot in fact make get average as a static method because it involves the usage of object instances properties. However, get student count is returning static variable, static field called the student count. Okay, so if you actually go back here, where is the static variable here? Yeah, so we have a static variable called the student count. Okay, so in this case, we are going to make this get student count method a static method because it works with the static variables. So in fact, if you try to access instance variable within the static method, that's a compile error. So all these things will be actually becoming somewhat obvious. You don't really have to memorize all these things. When you actually start coding, compiler will let you know, and then you can find out why compiler complains, and it's easy to fix. So you don't really have to actually memorize all this. As long as you understand the concept, that should be good enough. Okay, so this is a sample application called the student record example class. It has a main method, and here we created 3 object instances of student record class. Okay, and then you're using setter method, setting the name field of each of object instances. So the first object instances will have a name field set with Anna. The second object instance, this guy, has a name field set with B, and the third object instances will have name field set with Chris. So you can see the name field of these three object instances will have different values. Okay, so in order to access the name private field, you want to use a getter method. So you're going to call Anna record.getName method, and it will return string object, which is Anna. And here we are calling static method, get student count static method, and static method, as we talked about several times, is from the class itself, student record class itself. Okay, so this is what you get. Concept of overloading methods, or method overloading. So basically, you can have the same name of methods the multiple times, meaning you can have multiple methods having the same name as long as their signature, the parameter signatures are different, meaning they have either the different number of parameters or the types of parameters are different. As long as Java is concerned, they are different methods. Okay. The reason you want to use overloaded method is when you want to have similar functionality but have a different implementation depending on the situation. Okay, so let's see examples. So here, this is an example of method overloading. As you can see, the name of the method is the same, print. However, in this case, the number of parameters are different. We have 1 and we have 3 in this case, and even actually the type of parameters are different. Okay, so they are the overloaded methods, and again we provide a different implementation. But again, these are considered completely different method as far as Java is concerned. This is more or less for the coding standpoint. Okay, so this is an example of using those overloaded method. So here we are using print. We are calling print method, but we are passing the string object, just one string object. So in this case, Java knows that it's supposed to call the first method, this guy. Okay. Now in the second case, it's containing 3 the parameters. Okay, so Java knows it has to call this. Okay, and of course, if there is no print method that matches the type and number of parameters, then that is a compile error. Okay. Okay, so in this case, we'll have an output like this. This is a first call to print. So this is the printing these things, and here we are printing out the grades of Anna. Moving forward, concept of constructors, what we call sometimes constructor methods, because they are methods. So special methods. So constructors are used to initialize properties when object instance gets created. So constructors are important in instantiating object because this is where initialization happens. These are the constraints of constructor method. Because this is a special method, you have to follow these rules, otherwise it's a compile error. So constructor method has to have a same name as a class. Okay. A constructor is like another ordinary method. However, only the following information can be placed in the header of the constructor. So these rules have to be followed. So you can have either public so you can have accessibility identifier, or sometimes you call modifier, right? Like a public, private, and things like that. Okay, and this is important. Constructor does not have any return value. Okay, so if you include a method same name as your class and then has a return value, then it's a compiler. Okay, so compiler will tell you that, oh, it seems like it's a constructor method, but you're returning something you shouldn't. So that's what it's saying. You're not calling constructor method directly. Constructor method is actually called indirectly by the Java when object instance is created. Okay, so let's see the structure of constructor method. So you have modifier such as a private, public, and then you have a class name. And so this is like a method name, but has to be the same as a class name, and there is no return type. And then you can have a set of parameters, and then you can have some business logics. Okay. Let's see. Question from Mahesh. Does constructor can have different modifier than class modifier? So when we have modifier, I'm talking about public and private. Okay, so it is in fact the same set of modifiers that are applied to fields, the class, and the methods. The concept of default constructor. Default constructor is a constructor that does not receive any parameters. Now this is important. If you do not specify any constructor at all in your class, then default constructor gets automatically created by the platform, by the Java. Okay? If you have any constructor defined in your class, and then default constructor does not get automatically generated. Okay, so this is an example of constructor inside student record class. So this is default constructor example. So you say public, and this is the name of the class as a method name, and it doesn't have any parameters. So this is an example of default constructor. Again, if you don't have any constructor, whether it is a default constructor or non-default constructor, then default constructor gets created by the platform. So these are the constructor method, because it's a method can be overloaded. Okay, so in this case we have defined 4 different constructor methods. So this is the first one is a default constructor method, and here we are receiving a single parameter, and here we are receiving 2 parameters. Here we are receiving 3 parameters, and of course you can have different, let's say, set of parameters and different types. These are all considered as constructor method because, again, the rules of constructor method is the name of the method is the same as a class name. So in this case here, these constructor methods are inside the student record class. Now when you see, so we're going to talk about this later on. Okay, so I'm going to just move ahead. Okay, so how do you use constructor? So we know in order to create an object instance, we use a keyword called new, right? And then you provide the name of the class, and then you can provide a set of parameters. Okay, so when I'm using these syntax, passing one single parameter, then it will use this constructor. So it received the parameter, and then it will set the internal name variable with the value that was passed. Okay. Okay, so in this case we are passing 2 parameters. Okay, so the rules of overloading, method overloading works for the constructor method as well. So here Java will find, okay, so let me see if there is a constructor method that receive two parameters, and in this case the parameter types of which should be string type, so it will use in this case this. Suppose if you have, let's say, integer instead of string, and then if you're passing, let's say, string object like this, that's a compile error. Here we are passing integer type, 3 of them as a parameter, so Java knows, there is constructor method called the student record receiving, in this case, double type instead of integer type. Okay, moving forward, this constructor call, so this is really not that important. So this one is actually not, this is relatively important. My mistake, I was actually talking about something else. Constructor calls can be chained, meaning you can call another constructor from inside another constructor. And so we are going to use what is called the this for this. And these are the rules that you have to follow. When you're using this one, you have to be, it has to be as a first statement in a constructor. And it can be used only in a constructor definition. So let's see an example rather than talking about these rules. So here we have defined, let's say, 2 constructor method inside the student record class. Okay, so assuming these 2 constructor methods are inside student record class, and now we have a main class which contains a main method. So here we are going to call constructor method, the first constructor method, right? Because we don't pass anything. So the first constructor method is this, because this is one that doesn't receive any parameter. Now in this case, it's going to call this, and then it's passing some parameter. So what this means is that it's going to call another constructor method that can take this parameter. So we have another constructor method that takes the string type object, right? So this will call this constructor method. Okay, so the name field of student record object will be set. In this case, it's kind of hard-coded. Okay. Okay, so this reference, refers to current object instance itself, and is used to access instance variables, and the notation of is like a this dot something. So in our previous presentation, we were using this as, in a sense, a method, right? So another example that we are going to use here is we are using this as a reference of current object instance itself. Okay, so when you call this dot name of instance variable, what that means is that I'm referring to instance variable, meaning the instance property of this particular object, current object. Okay. Of course, you cannot use this dot in static method, because static method has no concept of instance, object instance, right? So that's a compile error if you try to use it inside the static method. Okay. So this is the slide that I don't think is that much important. This reference is assumed when you call a method from a same object. So when you call another method like this, this is basically the same thing as this dot another method. Okay. Yeah. All right. But yeah, this is not that much important. You are never going to have this kind of the usage in your Java code. But just conceptually, it is the same thing. Okay, now this is something you have seen many times, right? So here, when you have a method, okay, and it's receiving age as a parameter, now what this statement does is basically using the value it received as a parameter, now is setting the property or field called age of this particular object instance. Okay, so that's what this dot means, is current object. Okay, so if you don't specify this one, again, it will assume this is calling from this object. So this is the same thing as age colon age, but of course the age on the right side of the equal sign is from this parameter, and the age on the left side is property of an object instance. Okay, so access modifier. So this is actually something, probably the most complex concept of this presentation. Okay, so access modifier can be in 4 different forms: public, protected, default, and private. Okay, and public is the least restrictive, while private is the most restrictive. So this is in order in terms of level of restriction. By the way, public, protected, and private, you have to specify this keyword to have this the modifier. I mean, meaning to have this particular scoping based on this modifier. If you don't specify anything, then we call, in fact, the default the modifier, default scope, default the access scope. So let's talk about each of these in a bit more detail. So when you use public, by the way, I'm talking about both, the thing I'm talking about here, the accessibility is, is for the members of a class. So I'm talking about variables or properties, same thing, and the methods. So whatever I say here apply to both properties and methods. So when you specify public access modifier for your member variable or method, what that means is your method will be available to pretty much everyone. We haven't talked about the concept of a package, but the user of your, the caller of your method can be inside the same package or outside of the package. So this is basically open to everyone. So any object that interacts with the class can have access to public members of the class. When I say any object that interacts with the class, that means the user of your class. So let's see this example. So we have the student record class, and then we have this access modifier. So we set both name as public and the get name as public. Okay. Again, this is not really good. This is not really good practice. Typically, you want to make it private, but get name as public so that this is actually visible to outside. Okay. But just for the sake of syntax, you can set this one as public, and you can set this method as a public, meaning any user, meaning any other classes, whether they're in fact the same package or non-same package, can access this variable as well as this method. Protected access, however, specifies that class members are accessible only to methods in that class and the subclasses of the class. So the subclass can be in, by the way, the subclass can be in different package. Okay, so let's see an example in this case. So we have a student record class, and then we set, let's say, protected field called name and protected method called the get name. So in that case, these guys are accessible from any class in the same package. However, it could be also accessible from any class that is a child class, okay, of this class, even if it is in different package. Okay, so we'll actually take a look at this one from an example standpoint when you do the hands-on lab. So if you are a little bit confused, that's perfectly fine. Default access, meaning if you don't specify none of those 3 modifiers, meaning you don't specify public, you don't specify private, you don't specify protected, then it is default access. Default access is pretty straightforward. It can be accessible only classes in the same package. Okay, so again, the concept of package is a collection of classes in a tree structure. Okay. So here, if you don't specify private, protected, public, then it is considered as a default modifier. Okay, what that means is this variable or this method can be accessible from any class in the same package. Private means it can be accessible only within that particular class. Okay. So here we made it name, and we have get name both private. So it cannot be accessible outside of this class. Yeah, so this actually shows the scope of these access modifiers. Private variable and method can be accessible only within the same class. Default sometimes is actually package. The access mode is same class and same package, up to same package. Protected. In addition to these two, if there is a class, there is a subclass of this particular class, but even if it is in a different package, they can access it. Public, it doesn't, anybody can access that public member and field, even if it is not a subclass. Okay, so coding guidelines. Instance variables of a class should normally be private, so that it's hidden, so that client, meaning user of your class, cannot directly access to it. Okay, because it does cause the problem in terms of the encapsulation, meaning your implementation cannot change without affecting that user code. Okay, instead you want to use accessor and mutator, getter and setter method for the client to use. Okay, so we just learned how to define your own class, and we learned how to declare fields, both instance fields and static fields. And static field, by the way, is sometimes called the class field or class properties, and how to declare the accessor, getter method, and mutator, setter method, and also static method. We learn how to use a return statement. We learn about this, and we learn the concept of overloading. So same method name but different set of parameters or different types of parameters. And we talk about the concept of constructor. And we haven't really learned the concept of packaging. We're going to cover the concept of packaging later on when we talk about the class path and package. Okay, so this package concept is pretty important concept. So we have a separate session covering package. For now, you can think of package as tree structure based collection of classes. And then we have learned access modifier, default, public, private, and protected. Okay. Okay, I know I have a question from Rich. Let me just move on to the hands-on lab, and then let me just address those questions after we cover the hands-on lab. Okay, so basically we are going to exercise the concepts that we have learned in the presentation. So exercise 1 is creating your own class. So project name, and once you got the project, we are going to create a new Java class. Right click the project, select new and Java class, and we name it as student record. Okay. Typically you want to have your class on the particular packaging structure, but since we haven't learned the packaging, we are not really creating this class under a particular package. Okay, but in general you want to create it under a package. Okay, so we have the student record class, and here now we have defined 4 instance variables, and then we have defined 1 static variable. Okay, so this is the same this is the code that we have seen, and then we have defined 1 static method and another static method. So this one is increasing student count, and this is returning student count. So in terms of return type, if you don't have anything to return, then you have return type void. Okay, so you have to have return type when you define a method. If you don't provide any return type, then that's a compiler error. Okay, so if you don't return anything, then you have to specify at least void. Moving forward, and then this is another class. Here we are using the student record example class as a main class. So basically we create an object instance, and then we are using the static method of this the class to increase the student count. Okay, so Okay, it's relatively straightforward. So let me just move on. Okay, so exercise 2, we are going to exercise the static variables and static methods. So creating new project, we are going to name it as a variable, and then we are going to create a new Java class called the variables. Okay, so here we have defined 2 static variables. Okay, and then we have defined 2 instance variables. Okay. Okay, then we have static variables example, and here we are accessing static variables of the variables class. Okay, so you can see we are using just name of the class, so you can tell these methods are all static methods. Okay, now we are accessing instance variable of this class, so we have to create an object instance. So we are going to create an object instance using new, the name of the class, and we are using default constructor to create an object instance. We create a second object instance. Okay, and then we are basically setting the values. Now, static variables can be accessed from object instance. So far, the examples that we have seen is that we are using class name to access a static variable, and that's actually recommended. However, syntax-wise, it is okay to use object instance to access the static variable. This is not a syntax error, okay? Even though this is not recommended practice. Okay. So static variable can be accessed from multiple object instances, but the value should be the same. So we are accessing static int a, static variable, from 2 different object instances, but the value should be the same. Okay, because it's all shared by all object instances. Okay, moving forward. So now if you try to access instance variable using class, then it will say non-static variable instance. Non-static variable cannot be referenced from a static context, meaning you cannot use the class name to access the instance variable. You have to create an object instance and then access the instance variable, because instance variable is per object instance. Okay. So here we use static methods and non-static methods. Let's see this example. So we have static variable, and then we have a static method. Now this is something I haven't talked about. So you can have you can have the anonymous static method. Okay, so meaning it doesn't have a name. What it means is that this particular set of statement inside of this coding block will be executed when the class is loaded. Okay, so meaning when the class is used first time, this code get executed. So here, so let's say we have this, the static variable, static method, and this guy. So sometimes it's used to initialize, your static variables. Okay. All right. So let's see this code. So here, in this main method, we are calling a static method of this class, methods class. So what that is okay, so here we are actually accessing the static variable, right? Okay, so we are just accessing it. So what happens is this: when you are using a class like this, that's the time the class will be loaded to the JVM, Java Virtual Machine. Okay, in fact, it will create a class object. Okay, that's the time this code inside this anonymous static method get executed. So the first thing you're going to see is, if you see the result, you're going to see these 2 methods are in fact from this anonymous static block. Okay, and then the value of a will be accessed. Okay, all right. So what we have done in our code is we are basically we are trying to access the value of a, static in static variable A, and what happens is that the static anonymous static method will be executed. So that's the reason we are seeing these two. These two lines are actually from the anonymous static method, and then it's displaying the result of the A static variable. Okay, so that's probably the most important. Let's move on. Overloading is pretty straightforward concept. So here we have a myPrint method without any parameter, and we have myPrint method taking one single string parameter, and then we have a myPrint method taking the string and double as a parameter. Okay, so depending on the what you're passing as a parameter, different. Here I'm talking about this guy, right? So depending on what you pass as a parameter, the correct method will be chosen by the platform. Okay, all right, moving forward. Constructors. So we have default constructor, which doesn't take any the parameter, and then we have second constructor, which take one parameter, and then we have the third, and this is fourth. Okay, and we have in fact 5. 1, 2, 3, 4, 5. Okay, so since we talked about in the presentation, let me just move on. Okay, so here again, depending on what you pass, okay, when you create an object instance, correct constructor method will be chosen and will be used. Okay, so this is a case that we are using the second constructor method. Okay, all right, moving forward. It's relatively straightforward. Training constructors via this method. So this is something that we have seen as well. So here, when we are, so this is actually something that you probably seen once in a while. So depending on the number of parameters, in fact, it's actually calling. So here we have received the 2 parameters, right? And then it's going to use the first constructor method that takes the first parameter, and then it's going to set the instance variable. Okay. Okay. So this is an example of chaining. All right. This reference is so this is the same thing. This is the same thing as this. Okay, again, this is rarely used, this syntax. Okay, so here we have so you're trying to invoke instance method inside the static method, and that's a compiler. Okay, so this is something we talked about. This as a reference. Okay, so this is something. Yeah, this is actually important. So I have a dummy class, and it does have my method 1 instance method, and then I have my method 2 instance method, and I have third instance method called my method 3. Okay. And so in the main application, I'm going to call. Let's see. I'm going to. Okay, this is So the main method is the same. It's basically calling my method 1. Okay. So in the main method, you're going to call my method 1, and then the result is going to be something like this. We'll see in the result. So when my method 1 is called, is calling my method 2, and is calling my method 2 again. Okay, so this is the same thing, but it's actually setting instance variable called S1 and S2. And then you can pass your object instance in the form of this. So in this case, your object instance is just another let's say parameter. Okay, object instance type. So here we are calling my method 3 instance method passing object of this object, meaning object instance of dummy class. Okay, so here is going to display. So what happens is that it's going to take object instance of dummy class, and then it will get the class name, and then it will display the string value of that class name. Okay, So it's going to be something like dummy class. Okay, so the key point here is that you can use this as a parameter. Okay, yeah, so this could be a little bit confusing. Okay, so I should actually show the main method. So main method is the same as here, this main method. Yeah, so this is a main method. So what happens is that I create a dummy class object instance, right? And then I'm calling my method 1 instance method. So when you're calling this instance method, the object instance represented by D1, that is represented by this we are talking about. This. Okay? Alright. Alright, so let's move on to so in this case we have define instance variable hello and bye, and here we are passing this object instance, and also we are passing the string object represented by this bye. Okay, so it will display this guy and this guy. Okay. Alright, so access modifier. So we got about 5 minutes. So let me, so I'd like to finish this one. Okay, private, protected, and default and public. So let's see. We have a dummy class. And we have main class. Okay. So let's actually see the dummy class. So dummy class, we have private variable S1, and then protected S2, and public S3, and then this is default. Okay, so just remember this. S1 is private, and S2 is protected, and S3 is public, and S4 is default. So let's just repeat one more time. Private field means it can be accessed only within the same class. Okay, and protected means it can be accessed in the same package, any class in the same package, and however, it could be also accessed by some subclasses of its own, even if the subclass is in different package. If it is in the same package, and of course it will be accessible. But even if it's a different package, as long as it's a child class of this dummy class, then it should be accessible. And we'll see that example in a few minutes. Default mode is this is accessible only within the same package. Public, anybody can access this. The same thing for the method. So here we have a private for the method, protected for the method, and public for the method, and void. So the rules are the same regardless whether you're accessing a member variable or the method. Okay, so here, we have the method in another class called the main, and then we create a dummy class object here, right? And now we are trying to access S1, S2, S3, and S4. Okay, so this one, S1, should cause compiler error because you're trying to access a private variable of dummy class. Okay, so main is a different class, right? Even if in the same package, it's a different class, so you cannot access private member of this dummy class, so compiler error. These four should not cause compiler errors because S2 is protected, right? So as long as this is the same package, it should be accessible. S3, it is in this is public, so of course it can be accessible. S4 is default, again, as long as in the same package, should be accessible. Same deal for the method. So the first one, when you're trying to access method 1, which is a private method, it's a compiler error. So you're going to see these two compiler errors like this. So it says S1 has a private access in dummy class, meaning it's a private member of another class and you can't access it. Okay, same thing for the methods. Now here we are trying to access modifiers from a different package. Again, we haven't talked about the concept of package, but again, you can think of package is actually another set of classes in a tree structure. So we create a new package. So we have one package called the my_access something, and then we're going to create another package, new Java package, and we're going to name it as a my new package. Okay, so we have my_access modifier example something package which contains dummy class and main class, and then we create another package, and then inside this new package called the my new package, we are going to create dummy class 2 class. Okay, so we are going to create a new class under it. Okay, and we are going to call it dummy class 2. And so now we have the dummy class 2, and so we are going to create dummy class object. This dummy class is in a different package, so you have to use what is called the import statement. Okay, if you don't have this statement, it's a compiler error. Okay, so again, we'll talk about that concept in a bit more detail later on. So we create a dummy class object instance, and now you're trying to access S1, S2, and S4. Okay, public is you should be accessed anyway. So here we are actually trying to exercise S1, S2, and S4. They should have all compilers. Okay, private you can't access it regardless, and protected method, because this is different package, and because S2 and because the dummy class 2 is not a subclass of dummy class, it cannot access the protected variable. Same thing for the default variable. They are not in the same package. Okay. Now we are going to create another class called the dummy class 3. So dummy class 3 now extends dummy class. So this is a child class of dummy class. So we haven't talked about the concept of the extension or concept of inheritance yet. When you extend a parent class, all the member variables and member methods of the parent class can be readily usable. So here in dummy class 3 method, I am trying to access S1, S2, and S4, which are in fact member variables, and the same thing with the methods. Trying to access those parent variables. Okay. Now this one should result compiler error. Okay, because you're trying to access a private variable, even if you're a subclass, meaning even if you're a child class of dummy class, you still can't access a private member of your parent class. So this is a compiler error. However, this one you can access it. Okay, because S2 is protected member, and dummy class 3 is a child class of dummy class. So even if they are in fact different package, it can still access it. Default, regardless whether you're a child or not, can be accessible only within the same package. So in this case, dummy class 3 is a different package, so it should it fails. Okay, so this is what you will see. So you will see two failures on the member variable and 2 failures on the method, but the protected variable and protected method can be accessible. Okay, so that is the end of, let's say, the hands-on lab. So let me finish